Hey everyone, today I am going to present COA presentation on increment and decrement counter in 8051 assembly. These are the contents of the assignment and introduction. Assembly language is a low level programming language that interacts directly with CPU registers and memory. It uses mnemonics like move, ink, dic instead of binary instructions help in understanding microcontroller architecture and instruction flow. 8051 assembly is widely used in embedded applications like counters, timers, and device controls. Let's see objectives to implement increment and decrement counter operations in 8051 and to understand the interaction between memory registers and the accumulator and to observe the loop controls using CJNE and unconditional jumps and to verify program correctness using KLive vision simulators. Next we will see the problem statement. There are two problem statements. One is increment loop and another one is decrement loop, which is increment loop starts from 00h and counts up to 0h and update memory location 84h with each value, and decrement loop start from 0h and count down to 00h and update memory location 84h after each decrement. Both loops demonstrate register memory interaction through indirect addressing mode using R0. Let's see the algorithm for both loops. This slide shows the algorithm for both increment and decrement loops. In this increment loop, the microcontroller starts with the accumulator value set to 00h and repeatedly increment it by 1. Each new value is stored in memory location 84h. The loop continues until the accumulator reaches 0h. Similarly, the decrement loop, the process begins from 0h and the accumulator is decreased by 1 each time. Again, the updated value is stored in the same memory address and the loop runs until it reaches 00h. Let's see assembly code for increment loop. The instruction move R0 and hashtag 84h loads the address 84h into register R0. Move A slash 00h initialize the accumulator with 0. The increment A instruction increases the value of A by 1 and move at R0. A stores that new value into new location memory location 84h. The CJI instructions checks whether A has reached 0h. If not, the program jumps back to the label increment loop. Finally, SJMP creates an infinite loop to stop further execution. Let's see assembly code for decrement loop. This part shows the decrement counter. Here, move A slash 0h initializes the accumulator with 0ah. Decrement A decreases the accumulator value by 1 and move at R0. A writes that value into memory. The CJNA instruction checks if A has reached 00h. If not, the program repeats the loop from the label decrement loop. Finally, SJMP holds the program at the end to prevent it from running into understand undefined memory. Let's see memory register sequence. This table show how value in the accumulator register R0 and memory change during execution of both loops. In the increment loop, A and memory start from 00h and go up to 0ah. R0 remains fixed at 84h since it is the pointer to the memory location. As we should see down in the decrement loop, A starts from 0ah and decreases step by step to 00h. Each new value is again stored at 84h. This clearly shows the synchronization between accumulator and the memory location during each iterations. And next we will see the instructions choice, why increment and decrement. In this experiment I choose the increment and decrement instruction because they are the most efficient for counter operation in the 8051 microcontroller. Both instructions are single byte and single cycle, which means they take less memory and execute faster compared to other arithmetic operations like add or sub, Another important advantage is that increment and decrement do not affect the carry flag, so they are the ideal for simple looping or counting where we only need to increase and decrease a value without involving arithmetic carry. As shown in the table, increment A and decrement A execute faster than the add or sub, which are 2-byte instructions, and modify the carry flag. Therefore, using ing and dic makes the program simpler, faster and more efficient, which is very useful for looping and time-based applications. This is the results, which increment loop memory location 84H cycles from 00H and 0H. Decrement loop will memory location 84H cycles from 0AH to 00H. And coming to conclusion, successfully implemented increment and decremented counters, learned register memory interaction and indirect addressing, and observed in efficient looping and flag control, and simulation verified in KLI viewation, and future scope is extend to multi-byte counters, integrate with timers, or use interrupts for event counting. Thank you.